This is question 19 from the second CSAT sample paper. We're told that x is a quantity where dx by dt is equal to x minus 1 times 2x minus 1, and that when t is 0, x is 0. And we're asked for what value of t, so after how much time, does x reach half of its ultimate value. So we've got to figure out what ultimate value means and when x reaches half of that. So if you want to have a go at this question yourself, pause the video now. Okay, so first things first, we really want to get x equals. This is obviously setting this up as a differential equation because it's giving us dx by dt and it's giving us a boundary condition. So let's solve this differential equation. We can just divide both sides by x minus 1 to x minus 1, multiply by dt and integrate. So when we do that, what do we get? We get dt equals dx over this, or just t equals the integral of dx over x minus 1 to x minus 1. And hopefully you've seen this kind of integral before. The way to do this is partial fractions. So we split up the inside into partial fractions. It turns out that 1 over x minus 1 to x minus 1 is the same as 1 over x minus 1 minus 2 over 2x minus 1. If we just check, we get 2x minus 1 on top, minus 2x, so the x's cancel, and then plus 2, so we get plus 1 on top. And now this is easy to integrate. This just goes to log of x minus 1. This goes to, well, it looks like log of 2x minus 1, and that actually works because we've got this 2 on the top, which undoes the chain rule for us. So we get log of, I've put the mod signs in because we don't know what x is, so x minus 1 could be negative. So we want log of mod x minus 1 minus log of mod 2x minus 1 plus a constant of integration. Bear in mind we've been given a boundary condition when t equals 0, x equals 0, so we definitely want to include this constant. And now we'll work out what it is. Bear in mind I could have made this log of a fraction, but I chose to write it this way for now. So we'll work out what c is. When t is 0, this side is 0, and here we have log 1 minus log 1, both of those are 0, plus c, so we have to have c equals 0. So if x and t are both 0, we get c equals 0, and therefore t is just the difference of these logs, which is log of a fraction. So t is log of mod x minus 1 over 2x minus 1. So bear in mind we want to know the ultimate value of x. What does that mean? Well, what we could do is we could rearrange this to get x. It's a little bit difficult because of the mod sign, so you're basically going to have a plus or minus in there, and then you have to work out which of those cases is possible given the information you have. I don't want to do that much work. I want to do it quickly if I can. So let's actually leave it in this form. What does the ultimate value mean? Well, either there's going to be some maximum value of t, so as t goes to infinity, this is going to stop making sense. Or, as t goes to infinity, x is going to tend to some limit. And when I say x's ultimate value, it does sound like the value of x in the limit as t goes to infinity. Because otherwise they would have said final value, or largest possible value, or smallest possible value, depending on which it is. But they said ultimate value, which isn't something you hear a lot. It does sound like someone trying to describe the value in the limit. So let's think about what happens as t goes to infinity. That means we want this log to go to infinity, so we want the inside to go to infinity. And how can we get the inside of this to go to infinity? The only way is if the bottom goes to 0, which means x is going to a half. So the only way t can go to infinity is if x is going to a half. So we're just saying as t goes to infinity, we want the inside to go to infinity. And therefore we want x to go to a half. So a half is the ultimate value of x. Another thing you could do is draw the graph of this and then draw the graph of mod of that and then draw the graph of log of mod of that. And you can see what happens as t goes to infinity. And you can read this off from there, but it's much quicker to do it this way. So now we know the ultimate value. What are we looking for? We want to know the time taken for x to reach half of that. So that means we want it to reach 1/4. So we're just setting x equals 1/4 and we're working out t. So when x is 1/4, we just plug that in. On the top we get bear in mind everything's in mod sign, so we don't have to worry about minuses. Although they'll cancel anyway. So on the top we get minus 3/4, quarter minus 1. On the bottom we got a half, minus 1 is minus a half. If we multiply top and bottom by 4, we get, and cancel the minuses, we get 3/2. So we've just got log of 3/2. You could write this as log of 3 minus log of 2, but it's not really, I can't really say one way is better than the other. So log of 3/2 is fine as a final answer.